problems on Rolle's theorem. Then I will move the next two theorems, Lagrange's theorem and Cauchy's theorem. Okay.
Sir,
Let us take examples on Rolle's theorem.
sir, can I ask a doubt, sir?
Okay, please ask me.
సార్ లాస్ట్ టైం రోల్స్ థియరం దగ్గర మీరు చెప్పినట్టు అది ఏ ఫంక్షన్ అయినా సరే ఫంక్షన్ డెఫినేషన్ బట్టి రోల్స్ థియరం అప్లై అవ్వాలంటే విత్ ఇన్ క్లోజ్ లిమిట్ ఉండాలి, నెక్స్ట్ ఎఫ్ ఆఫ్ ఏ ఈజ్ ఈక్వల్ టు ఎఫ్ ఆఫ్ బి అవ్వాలని చెప్పారు కదా.
క్లోజ్డ్ ఇంటర్వెల్ మీద కంటిన్యూస్ ఫంక్షన్ కావాలి అండ్ ఆన్ ఓపెన్ ఇంటర్వెల్ డిఫరెన్షియబుల్ ఫంక్షన్ కావాలి అండ్ ఇంక్లూడింగ్ దిస్ ఎఫ్ ఆఫ్ ఏ ఈక్వల్ టు ఎఫ్ ఆఫ్ బి కావాలి. దెన్ ఓన్లీ ఇట్ మస్ట్ బి సాటిస్ఫైస్.
సార్ ఒకవేళ ఎక్స్పోనెన్షియల్ ఫంక్షన్స్ ఉన్నాయి కదా ఎక్స్ స్క్వేర్ అవన్నీ వాటికి అప్లై అవుతుందా?
చేస్తాను, ఇప్పుడు అదే ప్రాబ్లమ్స్ తీసుకొని చెప్తాను, మీకు ఎక్స్ప్లెయిన్ చేస్తాను. ఓకేనా?
ఓకే సార్.
ఓకే. Now today I will going to discuss on that exponential functions, trigonometric functions, some algebraic functions. Okay. Let me do certain examples, then automatically your doubts will be clear. Okay.
Okay.
Right. Shall I start the problems?
Sure, sir.
Here. Okay. Is it a screen is visible? Yes.
Visible, sir.
Yes, sir.
Okay. So last class we finished this Rolle's theorem proof. Now come to the some examples on this Rolle's theorem. Okay, let me take first simple example, that is fx equal to sin x. So fx equal to sin x and see what about intervals. The function is fx equal to sin
Sir,
x.
page number, sir.
Okay, in your textbook it is page number 133. 133. And the intervals are 0 to 2 pi. Okay. So now we have to do one by one first. See here. Screen కనపడుతుందా? Yes.
Yes, sir.
Right. F of x equal to sin x and it is the function is 0 to 2 pi. Now I want to check out for these function the Rolle's theorem is existing or not. So if it is exist means just find out the c value and check out whether the c is within this open interval 0 to 2 pi or not. అంటే నాకు వచ్చే c value whether it is belongs to open interval 0 to 2 pi or not. If the theorem is exist, definitely that c value must be within this open interval 0 to 2 pi. Let me check out one by one. So first come to the solution part. So first what about condition? F must be continuous function. F is continuous function on flow interval 0 to 2 pi. So how we are going to check out this? By taking certain graphs. If you put a sin function is f of x is sin x. If you put x equal to 0, sin 0, 0 exists. So let us take in between 0 to 2 pi interval, take any values within this interval and draw the graph. Whether it may be continuous curve or not. Like this, we'll get the curve is like this. Okay, x equal to 0, sin 0, x equal to pi by 2, 1. That is, we'll get here x equal to 2 pi. Again, it is 0. So there is no gaps. So we'll get the curve is compulsory. We'll get the curve is continuous function. So f is continuous and flow interval oblique. Next, if it is continuous function, we know that every continuous function is differentiable function. Therefore, f is differentiable on open interval 0 to 2 pi. After checking this, go for this third condition. This third condition is important. What about the third condition of Rolle's theorem? F of a equal to f of b. So it is equidistances. So here a equal to 0, b equal to 2 pi. Let me check out whether f of 0 equal to f of 2 pi or not. F of x equal to first x equal to 0. That is x equal to a equal to 0 here. So f of x, that is f of a, that is f of 0. So sin 0. So 0. F of b means f of b means f of 2 pi. So f of 2 pi means sin 2 pi. What is sin 2 pi? Sin n pi is always 0. Whether it may be sin 180 degrees, sin 360 degrees, sin n pi for all n equal to 1 to infinite, sin n pi is always 0. Whether it will be 1 pi, 2 pi, 3 pi, all n pi are 0 for all values of n. So sin 2 pi also 0. So I got f of a equal to f of b. That is f of 0 equal to f of 2 pi. Both are 0 zeros. So this function within these intervals is satisfying the three properties of Rolle's theorem. F is continuous on closed interval 0 to 2 pi. F is differentiable on open interval 0 to 2 pi, and f of a equal to f of 2 pi. Therefore, if there exists at least one point C belongs to open interval 2 comma 0 comma 2 pi. At this point, the function derivative must be equal to 0. Is it clear? There exists at least one point 0 to 2 pi, and at this particular point, the function derivative must be equal to 0. This is check them. So, what is f of x here actually? Sin x. Okay, what is f of c? Just I am converting the function in terms of c multiples. F of x equals sin x. F of c will become sin c. Now take differentiation with respect to c. So f dash c will become sin c differentiation cos c. So this is f dash c. But according to Rolle's theorem, what about condition? F dash equal to 0. Therefore, f dash equal to 0. It means f dash equal to 0. It means cos c equal to 0. See here, in cos theta, for what values of theta, it will become 0.
M pi by 2, sir.
Yes, cos equal to 0. Cos lo 0 eప్పుడు వస్తుంది? Cos equal to cos 0, 90 degrees, pi by 2. Okay, what is cos 90? Cos 90?
0.
0. So c equal to 90 degrees. I got c equal to 90 degrees. So c equal to pi by 2. Is it belongs to open interval 0 to 2 pi? Yes, it is always 0 to 180 degrees. Pi by 2 it is always belongs to 0 to 2 pi. So hence the Rolle's theorem is verified. So after getting the c, just check out whether this c value is within the open interval 0 to 2 pi or not, within the given in open interval. So as for here in this example, f is continuous on closed interval 0 to 2 pi, f is differentiable on open interval 0 to 2 pi, and f of a equal to f of b, that is f of 0 equal to f of 2 pi, and c equal to, I got finally 0 to 2 pi by 2. This is belongs to 0 to 2 pi. Therefore, the Rolle's theorem is verified, because I got c value within this interval with the help of this condition f dash equal to 0. Okay, so like this we have to check out the Rolle's theorem conditions. Similarly, if you take one more example, see here. Yes, e problem ardhaminda.
Yes, sir.
Yes, sir.
Just check out c constant value within the open interval or not. Let us take some more examples. Yes. So this, let us check out 0 to, okay, this is over. Similarly, check out 1 by x also. Yes, f of x, this is important from here. F of x equal to x minus a whole power m, as in our textbook, page number 135, into f of x equal to x minus whole power m into x minus b whole power n. For all closed interval a comma b, and where m comma n are positive integers. The question itself is giving m comma n belongs to z plus. Now we have to check out this problem is satisfying the Rolle's theorem or not. See here, f of x equal to x minus whole power m into x minus b whole power n for all a comma b, and where m comma n, what about m comma n values? As m comma n belongs to z plus. For this question, I'm going to check out the Rolle's theorem. Okay, see here, this is f of x equal to, so this is question, and coming to the solution. So first we have to see that the three properties. So first condition, obviously it is true, f is continuous on closed interval a comma b, because within this a comma b, if you know the a b values, then I can draw the graph. So I am writing f is a continuous on closed interval a comma b, and f is differentiable on open interval a comma b. And what about the third condition? This is we have to check out. Third condition, f of a equal to f of b. See whether it is equal or not. So first, what is f of x? X minus a whole power m and x minus b whole power n. If you put x equal to a, f of a will become a minus a whole power m and a minus b whole power n. So a minus a. So this is 0 into something. Totally we will get f of a equal to 0. Similarly, x equal to b, that is f of b. So again, f of x is this. In this, I'm going to substitute x equal to b. So b minus a whole power m into b minus b whole power n. Again, b minus b means it is 0. So 0 to something, it is totally 0. So f of b also I got 0. So f of a 0, f of b 0. Therefore, these problems satisfying
Kumari Bazar.
yes, no talking. These
Kumari
problems also
Bazar.
satisfying the third property of Rolle's theorem. Therefore, f is continuous on two interleaved b, f is differentiable on open interleaved b, and f of a equal to f of b means there exist the, therefore f is satisfying the three properties of Rolle's theorem. Therefore, there exists c belongs to open interleaved b is such that f dash c must be equal to 0. So f dash c equal to 0 is c kanukundam. What is f of x here? F of x is x minus a whole power m, x minus b whole power n. Okay, and f of c will become, just I am converting f of x in terms of f of c multiples. So just put x equal to c. So c minus a whole power m, c minus b whole power n. So for this, take differentiation with respect to c. So f dash c will become, yes, this is u, c terms are in here and here. So apply the uv formula. What about the uv formula? U v dash minus u dash v. So c minus a, I am writing u as it is, c minus whole power m, and c minus whole power n means n into x to the power of n minus 1 formula. N into c minus b whole power n minus 1. For internal function, for c it is 1, for b it is 0. So this is completely uv dash plus uv dash plus u dash v plus u dash. U dash means first
Excuse
time
me,
writing
sir.
this is mute చేస్తాను చూడమ్మా. Yes.
Thank
I
you.
will mute all.
ఆడేమో రావట్లేదు.
See here. So this is f dash c, that is u v dash plus u dash v. U v dash means c minus whole power m into c minus b differentiation is n into c minus b whole power n minus 1. For c minus b it is 1 minus 0. Next u dash v. So u dash means here I am writing c minus b whole power n is as it is, and c minus whole power m differentiation m into c minus whole power m minus 1. Again, for internal function, for c it is 1, a it is 0. So 1 minus 0. So totally we will get n into c minus a whole power m into c minus b whole power n minus 1 plus here also m into c minus a whole power m minus 1 into c minus b whole power n. Okay, this is f dash c value. But according to Rolle's theorem, f dash c equals 0. So just equating this entire right side value equal to 0. So f dash c equal to 0. It implies, yes, it implies as n into c minus a whole power m, c minus b whole power n minus 1 plus m into c minus a whole power m minus 1 and c minus b whole power n. This total factor will goes to 0. Now let us take any common multiples here. So c minus a whole power m, and here c minus whole power m minus 1. So this is m, this is m minus 1 means least term will be common. So c minus a whole power m minus 1 common. Similarly, coming to the c minus b, here c minus b whole power n minus 1 is there, but here c minus b whole power n is there. So least term is c minus b whole power n minus 1 is common. So c minus b whole power n minus 1 common. After taking these two terms common, come to the first. Here in first quantity n into, I have taken c minus whole power m minus 1 common, but here c minus whole power m is there. Still there will be c minus whole power 1 will be there. So if you want to doubt, just take the multiplication. C minus whole power m minus 1 into c minus whole power 1. So here bases are same, powers can be added. So m minus 1 plus 1, 1 get cancelled, we'll get c minus whole power m. Similarly here C minus B whole power n minus 1. This entire term I have taken common. So in first term, we will get only n into C minus whole power 1 plus. Similarly, second m into, so here C minus whole power m minus 1 I have taken complete common. But here C minus B whole power n is there. So C minus B whole power n low, C minus B whole power n minus 1 I have taken common. So still there will be C minus B whole power 1 will be there. So we don't want to check just only. C minus B whole power n minus 1 into C minus B whole power 1 means bases are same. Powers can be added. So C minus B whole power m minus 1 plus 1. Minus 1 plus 1 get cancelled. We'll get C minus B whole power n. Okay, equal to 0. Next. So it is A dot B dot C equal to 0 is there. Product of three terms. This A and this is B, this is C. So A dot B dot C equal to 0 means either A equal to 0 or B equal to 0 or C equal to 0. But here A does not equal to 0. C minus A whole power m minus 1 does not equal to 0. Why? Because if you take C minus A whole power m minus 1 equal to 0 means if this total term equal to 0, then the function will go to 0. Because what is our function? F of x equal to x minus whole power m into x minus b whole power m. So if it is x minus whole power m is 0, then this total function will go to 0. Similarly, C minus b whole power n minus 1. So if this is tends to 0, then again the entire function will go to 0. So here this function does not equal 0. This function does not equal 0. So the rest of the function n into C minus a plus m into C minus b will goes to 0. So then simplify them. Therefore, see here. So n into C minus a plus m into C minus b. Only this factor will goes to 0. Among these three, first term not equal 0, second term not equal 0 means n into C minus a, m into C minus b will tends to 0. So then simplify this only. So multiply with this nc minus na plus mc minus mb equal to 0. From this, write down all C multiples one side without C multiples one side. So nc plus mc equal to, I'm taking this minus na right hand side and minus mb right hand side. So it will become plus na plus mb. So in this, shall I take c common? If you take c common, it will become n plus m equal to na plus mb. From this, c equal to na plus mb by n plus m. Okay, this is c value, but we don't know whether it is belongs to open interval a comma b, but definitely it is belongs to open interval a comma b. So if you have doubt, please check out by putting n and m values, some numericals. Okay, this is c, which is always belongs to open interval a comma b. Check them whether it is belongs to or not. Okay, so I'm going to take for verification part, come to the a comma b. I'm going to take the interval a equal to 1, b equal to 2. You can take any one, a equal to 1, b equal to 2. And what is the nature of mn? In the statement itself is given mn belongs to z plus. So shall I take m equal to some 3, n equal to some 4. Okay, as this belongs to z plus. So n equal to 3 is n equal to 4. And intervals are ab. So what is c formula? C equal to na plus mb by n plus m. Therefore, n means 4. 4 into a, 4 into 1 plus m. M means 3. 3 into b means 2. 3 into 2 by m plus n. M plus n means 3 plus 4. So this is 4 into 1, 4 plus 3 into 2, 6. 4 plus 6, 10. 10 by 7. Is it 10 by 7 belongs to open interval 1 comma 2? Yes, 10 by 7 means 1 point something will get. 7 1 is 7. This is 3.0. 7 3 is 27. So we'll get 1.3 something. So it is always belongs to open interval 1 comma 2. Hence the Rolle's theorem is verified. So this is the C formula. Whenever the question is like this, f of x equal to x minus a whole power m, x minus b whole power n for all a comma b, and mn belongs to z plus n, then the C will be like this: C equal to na plus mb by n plus n. So for verification part, randomly I have taken certain values of ab and certain values of mn. Not only for this, you can substitute any ab values or any mn values. Definitely C must be belongs to open interval a comma b. Then an open interval 1 comma 2 తీసుకున్నా, after taking this formula I got to c is 10 by 7. This 10 by 7 always belongs to open interval 1 comma 2. It means the Rolle's theorem is verified. Okay. Yes. Is it understood? Ardhamayindi problem?
Yes, sir.
Okay. So I will take some exponential functions. It is an example of algebraic. So let us take one exponential function. Okay. Yes. See here. Here, of course, this is 2 plus x minus 1. It is also similar algebraic equation. Check this one. Yes. I will explain these problems here in your textbook. Yes. F of x equal to page number 136. Example 6.2.5. What is our question? F of x equal to, yes, this is important problem, sin x by e power x for all x belongs to 0 to 5. Okay. Now coming to the solution. He is asking verify the Rolle's theorem for this problem. Okay. Verify it. Yes. See here. F of x equal to sin x by e power x for all x belongs to 0 to 5. Okay. I have to verify Rolle's theorem for this function. F of x equal to sin x e power x. So first I'll write directly the conditions. F is continuous on flow interval 0 to pi. Okay. And f is differentiable on open interval 0 to pi. And what about third condition? We have to check out this third condition compulsory. What about third condition? F of a equal to f of b. Let me check out whether f of a equal to f of b or not. Here a equal to, what about a? 0. This is a, this is b. Screen కనపడుతుంది కదా? Yes. Screen కనపడుతుందా?
Yes, sir. Yes, sir.
Right. Okay. A equal to 0. Therefore, f of 0 will become, f of 0 means what is our function actually? F of x is sin x by e power x. So f of 0 means sin 0 by e power 0. What is sin 0? 0. E power 0 1. So 0 by 1 means 0 by something, it is 0 only. Similarly, b is pi. So f of pi equal to sin pi by e power pi. But what is sin 180? Sin pi is always 0. So 180, 0 by e power pi. So again 0 by something, it is 0. So I got f of a 0, f of b also 0. That is f of 0 equal to f of pi. So these problems satisfying the three conditions of Rolle's theorem. That is, f is continuous on flow interval 0 to pi, f is differentiable on open interval 0 to pi, and f of a equal to f of b. Both are equal to 0. Therefore, then there exists at least one point C, which is belongs to open interval 0 to pi, is such that at this point the function derivative must be equal to 0. Let us check out. F of x equal to, what is f of x? Sin x by e power x. So just convert these x into c multiples by putting x equal to c. So sin c by e power c. For this, take differentiation with respect to c. So f of c will become f dash c. Now it is sin c by e power c is there. So apply u by v formula. What is u by v formula? V u dash minus u into v dash by v square. Okay. Here u is sin c, v is e power c. So denominator v square means e power c whole square. Okay. And v into e power c into sin c differentiation cos c minus u into, that is sin c into E4C differentiation. E4C. This is F dash C. But according to Rolle's theorem, what we have F of DC value? F dash C value is 0. So I am equating this value equal to 0. Therefore, F dash C equal to 0. And ఇది తీసుకొని C కనుక్కున్నాను చూడండి. F dash equal to 0. So that's why I am equating this F dash C, that is E4C cos C minus sin C E4C divided by E4C whole square means E4 2C. This value equal to 0. Therefore, if you take cross multiplication, 0 into 2C, it will become 0. So E4C into cos C minus sin C into E4C equal to 0. So here. So I got E4C into cos C minus sin C into E4C equal to 0. So here E4C is common. Okay. Shall I take E4C common? So if you take E4C common, E4C
minus sin C.
cos C minus sin C equal to 0. So again A dot B equals 0. So if you take right side, it is E4C will goes to 0. So cos C minus sin C equal to 0. So if you take E4C equal to 0, you will get the one root, one C value. And if cos C minus sin C equal to 0, if you solve this one, we will get the one root. So any one of the root must be belongs to C kavali. Open interval 0 to pi kavali. So then this solve just only. Cos C equal to cos C minus sin C equal to 0 means cos C equal to sin C. Now tell me, for what values of theta, sin theta equal to cos theta?
45.
For sin 45 degrees. If theta equal to 45 degrees, that is sin 45 equal to 1 by 2, cos 45 also 1 by 2. Okay. So whenever sin theta equal to cos theta, definitely theta must be equal to pi by 4. So cos C equal to sin C means C must be equal to 45 degrees, pi by 4. But is it belongs to 0 to pi? Yes, 45 degrees is always belongs to 0 to 180 degrees. Hence, the Rolle's theorem is verified. Okay. So finally, I got C equal to pi by 4. Hence, the Rolle's theorem is verified. So whatever the C value, we are getting that C is within the open interval 0 to pi. Therefore, so I can write here the Rolle's, hence the Rolle's theorem is verified. The Rolle's theorem is verified. Okay.
Sir, can we check for x square, sir?
And yes,
F of x is equal to x square.
yes, f of x equal to s. F of x equal to one more example, x square. Tell me what about interval?
Interval is about AB, sir. That's it.
Interval AB. Okay, let me check out. Okay, check that out. So first condition, yes, f is continuous on clonal A, B, because AB is constants. If you put AB equal to certain values, then I can draw the curve. Okay, so directly I'm writing f is continuous on clonal A, B. Second, f is differentiable. What is f of x square differentiation? 2x. Yes, it is existing. fx is differentiable on open interval A, B. And check out third condition. F of A equal to f of B or not. Okay, what is f of x here? Actually, x square. F of A means a square. But what is f of B? Means b square. But we don't know here a square equal to b square or not. Okay, so if f of A equal to f of B, if this is exist, then only I can move the next step. F dash equal to 0, C belongs to open interval A, B. But here I don't know AB values. I don't know AB values. So
A is
I
equal
cannot
to
say A equal to
B అయితేనే కండిషన్ సాటిస్ఫై అవుతుంది సార్.
ఖచ్చితంగా ఈ కండిషన్ చెక్ చేసే వెళ్ళాలి. బట్ హియర్ ఐ డోంట్ నో A square equal to B square. How can we say A square equal to B square?
ఓకే సార్, ఓకే.
Okay, if I say interval certain values, suppose this is, let us suppose f of x equal to x minus 1 whole square. Let us suppose x minus 1 whole square రాదు intervals. अरे माफ कर दो So here A square equal to B square I got, but we don't know whether A square equal to B square or not. If it is AB values are known, then I can check out whether f of A equal to f of B or not. But here they are constants. So for these kind of problems we can't say directly. If it is third condition also true, then I can move the f dash equal to 0 with the help of this. Then I can check out C belongs to open to A, B or not. Okay, right? Next, see here one more example. ఇది అర్థమైందా?
సార్ అర్థమైంది సార్.
ఏ స్క్వేర్ ఈక్వల్ బి స్క్వేర్ వచ్చింది. నాకు ఇక్కడ ఏబీ తెలియదు కదా, ఏబీ తెలిసింటే చెక్ చేస్తుంటే ఓకేనా.
అలా కాదు సార్, మీరు లాస్ట్ టైం అలా కాదు, లాస్ట్ టైం మీరు చెప్పినప్పుడు టాంజెంట్ గీస్తే అది ప్యారలల్ గా ఎక్స్ యాక్సిస్ అదే యాక్సిస్ కి ప్యారలల్ గా ఉండాలని చెప్పారు.
అయితే అక్కడ వస్తే టాంజెంట్స్ ఎగ్జిస్ట్ కావాలి, ఆ ఇంటర్వల్ మధ్యలో టాంజెంట్స్ ఎగ్జిస్ట్ అవుతాయి. ఆ ఇంటర్వల్ మధ్యలో టాంజెంట్స్ ఎగ్జిస్ట్ అవుతాయి.
ఎక్స్ స్క్వేర్ గ్రాఫ్ లోని కంటిన్యూస్ గా ఎగ్జిస్ట్ అవుతుంది కదా సార్ టాంజెంట్స్ అనేది.
ఎగ్జిస్ట్ అయితే నాకు ఇక్కడ ఏబీ వాల్యూస్ ఇవ్వండి, ఏబీ వాల్యూస్ ఇచ్చి నేను చెక్ చేస్తా. అది కూడా ఉండాలి, ఈక్వి డిస్టెన్సెస్ ఉండాలి, ఈక్వి డిస్టెన్సెస్ ప్రాపర్టీస్ కూడా సాటిస్ఫై చేయాలి.
ఓకే సార్, ఓకే, అంటే ఈక్వి డిస్టెన్సెస్ కూడా సరిపోవాలి.
రాదు, సరిపోతున్నా అప్పుడు నేను చెక్ చేస్తా ఎఫ్ డాష్ ఈక్వల్ 0 అని తీసుకోండి ఓకేనా. నీకు టాంజెంట్స్ ఎగ్జిస్ట్ అయితే మాత్రాన రోల్స్ థియరమ్ సాటిస్ఫై అయితే చెప్పనికి రాదు ఓకేనా.
ఓకే సార్, ఓకే.
ఇంకా డౌటా?
cos c minus sin c equal to 0 ఇచ్చాడు. టెక్స్ట్ బుక్ లో కింద స్టెప్ లో tan c equals to 1 అని ఇచ్చాడు కదా సార్.
ఏందమ్మా
ఇక్కడ స్టెప్ లో cos c minus sin c equal to 0 అని వచ్చింది కదా సార్.
cos c minus ఓకే చెప్తా ఇక్కడ ఎక్స్ప్లెయిన్ చేస్తా చూడమ్మా. cos c minus sin c equal to 0 కదా, cos c equal to sin c రాసుకుంటా ఓకేనా. సో దీన్ని రాసుకుంటా, sin c cos c తో డివైడ్ చేయండి ఓకే. దెన్ sin c by cos c will become tan c and sin cos c get cancel, tan c equal to 1 వస్తుంది ఓకేనా. అర్థమవుతుందా? for what values of theta in tan it will become 1 tan 45 degrees. Yes, tan c equal to tan 45 degrees, 5/4. Again I got c equal to 5/4. మీరు ఎట్లా చేయండి ఖచ్చితంగా ఆన్సర్ సేమ్ వస్తుంది ఓకేనా. రైట్, yes. Shall I move next problem?
Yes sir.
Yes.
ఇంకా హ్యాండ్ రైటింగ్ ఫాస్ట్ రాస్తున్నాడు. అంతకు ముందు అయితే ABCD కూడా అర్థం అయ్యేది కాదు అసలు వాడిది. ఇప్పుడు అర్థం చేసుకోవాల్సి వస్తుంది ఇంకా వాడి హ్యాండ్ రైటింగ్ చూసి.
Yes. Next here, come to the next Lagrange's theorem. Okay, Lagrange's mean value theorem. This is the second mean value theorem. It is also called the first mean value theorem. It is also known as first mean value theorem or Lagrange's mean value theorem. Now come to the statement. Come to the Lagrange's mean value theorem statement. Yes, Lagrange's mean value theorem states that first f is a function from interval a comma b to r.
Sir, page number
is such that పేజ్ ఒక నుంచి చెప్తానమ్మా. ఫస్ట్ ఒకసారి స్టేట్మెంట్ వినండి, నేను తర్వాత పేజ్ నెంబర్ చెప్తాను, ఒకసారి వినండి. సో f is a function which is mapping from interval a comma b to r with any function which is mapping from a to b r and it must be satisfies two conditions. Lagrange's theorem లో ఓన్లీ టూ కండిషన్స్ తీసుకుంటాం. Lagrange's mean value theorem లో, the Rolle's theorem lo there I have taken three properties simultaneously: continuous property, differentiable property and equality property. But ikkada em chestunnanu, yes, f is a, coming to the Lagrange's theorem, first two statements. F is a continuous function on interval a comma b. Second one, f is a differentiable on open interval a comma b. If the function must be satisfies these two conditions, then there exists at least one point c belongs to open interval a comma b is such that f dash c equal to f of b minus f of a by b minus a. అదే రోల్స్ థియరమ్ ఏమైంది, f dash equal 0 కి ఈక్వల్ చేసిన అంటే f dash equal 0 అయితే c must be belongs to open interval a comma b వచ్చింది. బట్ ఇక్కడ f dash c వాల్యూ ఏమొస్తుంది, f of b minus f of a by b minus a. This is Rolle's Lagrange's mean value theorem statement. We will explain once again here statement. Lagrange's mean value theorem statement: f is function from interval a comma b to r is such that f is continuous on clonal A comma B. F is differentiable on open interval A comma B. Then there exists at least one point C belongs to open interval A comma B is such that F dash C equal to F of B minus F of A by B minus A. Okay, this is statement. For proving this result, again I can use that Rolle's theorem statement. Okay, then proof first I will going to define one function phi of x. So for proving this Lagrange's mean value theorem, I will take one function S. Here. So Lagrange's mean value theorem, Lagrange's mean value theorem. So f is a function statement. F is a function from flow interval A comma B to R is such that two conditions. F is continuous on flow interval A comma B. Second one, F is differentiable on open interval A comma B. If the function must be satisfied these two conditions, then there exists at least one point C belongs to open interval A comma B is such that F dash C must be, means the function derivative at this point must be equal to F of B minus F of A by B minus A. Okay. Now come to the proof. Then proof is the proof of this theorem. For proving this result, I will define one function phi S, which is also mapping from flow interval A comma B to R, is such that phi of x must be defined by phi of x equal to in terms of f of x plus kx for all x belongs to A comma B. Okay. E theorem result prove cheyadaniki, yes, I am assuming one function phi which is mapping from flow interval A comma B to R, which is defined by phi of x equal to f of x plus kx. Okay, దీన్ని బేస్ చేసుకొని నేను ఈ Lagrange's theorem ప్రూవ్ చేస్తా చూడండి. So phi of x equal to this, then here as phi of a equal to phi of b check చేద్దాం. Phi of a equal to phi of b. So what is phi of x assumption here? F of x plus kx. So if phi of a means phi of a which is equal to f of a plus ka. In the place of x, I am putting lower limit a. Similarly, what is phi of b? F of b plus k of b. But here phi of a equal to phi of b anukuntunna. Okay. Therefore, these two left side quantities are equal, means f of a plus k of a must be equal to f of b plus k of a. Phi of a value is f of a plus k of a, which is equal to f of b plus k of b. So I want to find the k value. So let us take all k multiples one side and without k multiples one side. So k of a minus k of b equal to f of b minus f of a. From this, shall I take k common? K into a minus b equal to f of b minus f of a. From this, k equal to f of b minus f of a by a minus b. Okay, this is k value. So assume this is equation number 1. Similarly, come to the f dash x, phi dash x. So what is phi of x here? Phi of x is f of x plus kx. So what is phi of c? Phi of c will become in the place of x, just replace c. So f of c plus k into c. So take differentiation with respect to c. It will become phi dash c equal to f dash c plus k differentiation, kc differentiation, k constant, c differentiation 1. So I got phi dash c equal to f dash c plus k. Okay, next here. Yes. So k equal to this, and I got f dash c equal to f dash c plus k. Phi dash c equal to f dash c plus k. Next. Now here phi of x is f of x plus kx. But what is f of x? In the statement itself is given f of x is continuous and f is differentiable. It is satisfying the both conditions. and here f of x continuous, and here x is also continuous. F of x continuous, x is also continuous. So x into k. So if you multiply one scalar multiple with this continuous function, again the resultant vector also will belongs to continuous function. So fx is continuous, kx is continuous, means sum of two continuous functions. Again a continuous function means totally phi of x is also continuous on flow interval a comma b, and phi dash x is differentiable on open interval a comma b, and third one phi of a equal to phi of b. From this I got k equal to f of b minus f of a by a minus b. So here phi is satisfying the three properties of Rolle's theorem. Actually my original question is in terms of f, but for proving this Lagrange's theorem I have defined one more extra function phi of x. So for this phi of x, first I am going to check out all three properties of Rolle's theorem. With the help of this I can move this fx function. So here phi of x is continuous and flow interval a comma b. Into continuous aindi phi of x into define cheskunna f of x plus kx. So here fx is already continuous function in the statement itself is given. Fx is continuous and kx also continuous. So sum of two continuous functions is again a continuous function. So totally phi of x is continuous on flow interval a comma b, and phi is differentiable on open interval a comma b, and phi of a equal to phi of b. Then here phi is satisfying the three properties of Rolle's theorem. Therefore, then there exists at least one point C belongs to a comma b is such that phi dash c equal to 0. Already I got phi dash c equal to mundi f dash c plus k undi. Therefore, phi dash c equal to f dash plus c plus k. So phi dash c equal to 0. Therefore, f dash c plus k equal to 0. From this, shall I write k equal to minus f dash c? So assume this is the equation number 2. So I got two equations in terms of k multiples. From equation 1, k equal to f of b minus f of a by a minus b, and from the second equation k equal to minus f dash c. So equating the equation 1 and 2 are represents same here. So from equation 1 and 2, shall I write f of minus f dash c equal to f of b minus f of a by b minus a. So from this minus f dash c equal to f of b minus f of a by, in denominator actually it is a minus b, sorry, it is a minus b. Denominator we have a minus b here. So here if you take minus symbol common, minus of b minus a. So this minus get cancelled. F dash c equal to, finally I will get f of b minus f of a by b minus a. This is Lagrange's mean value theorem. Okay. So ఈ థియరం ప్రూవ్ చేయడానికి నేను ఈ అజంప్షన్ తీసుకుంటాను. ఇది ఒక్క అజంప్షన్ గుర్తుపెట్టుకోండి, ఆటోమేటికల్లీ we can derive the entire proof. Okay, for proving this result I am assuming phi of x equal to f of x plus kx. So one by one condition I am going to check out here. F of a equal to phi of a equal to 5 this much k ఎంత వచ్చింది, and phi dash తీసుకుంటున్నా. So here phi of x is continuous, phi dash phi x is differentiable, and phi of a phi of b base చేసినప్పుడు అంటే it is satisfying the three properties of Rolle's theorem. Therefore phi dash equal to 0 కావాలి. But what is phi dash c value? F dash c plus k. So phi dash c plus k equal to 0 means k equal to minus phi dash c. From these two equations, finally I will get phi dash equal to f of b minus f of a by b minus a. This is called Lagrange's mean value theorem. So in this one conditions here, so in this equation, suppose f of a equal to f of b and in Lagrange's mean value theorem, if f of a equal to f of b, then what is f dash c will become? F dash c will become, as these two are same, means if you put f of b equal to in terms of a multiples. So this is f of a minus f of a by b minus a. So again it will go to 0 by something, means total will get 0. That is f dash c will turns to 0. So whenever in Lagrange's mean value theorem, this condition is holds, that is f of a equal to f of b, again it will turns to Rolle's theorem. ఎందుకంటే నేను స్టేట్మెంట్ లో f of a equal to f of b తీసుకోవట్లేదు. But if you take f of a equal to f of b, again this Lagrange's mean value theorem will turns to Rolle's theorem. అంటే టోటల్ రైట్ సైడ్ వాల్యూ మొత్తం 0 అవుతుంది. ఓకేనా? అందుకో ఇక్కడ ఈ కండిషన్ మెన్షన్ చేయకండి. f of a not equal to f of b అది మెన్షన్ చేయదు. Simply only two conditions, f is continuous, f is differentiable. With the help of this, we will get f dash equal to f of b minus f of a by b minus a. This is Lagrange's mean value theorem. అర్థమైందా ఇది? Yes?
Yes, sir.
Is it clear? Shall we do some examples on this Lagrange's mean value theorem?
సార్
Pablo
టెక్స్ట్
explained it.
ఎక్కడ ఉంది చెప్పలేదు సార్ లాగిన్
చెప్తున్నాం షేర్ చేసి చూడండి. ఎస్ in your textbook it is page number 136, page number 136. Okay, any one of the examples probably should be. Yes, 141 example 6.3.4. 6.3.4. What is f of, you asking? Verify the Lagrange's mean value theorem for f of x equal to x square, sorry it is x cube, sorry, x cube plus x minus 4, and what about interval? On interval minus 1 comma 2. Okay, check jadam. See here. So x cube plus x minus 4. See here. String కనపడుతుంది కదా. So f of x is. So come to the solution. First, f is continuous on closed interval minus 1 comma 2. Second one, f is differentiable on open interval minus 1 comma 2. Then there exists at least one point c belongs to open interval minus 1 comma 2 is such that f dash c, what about Lagrange's theorem, f dash c value, f dash c equal to f of b minus f of a by b minus a. Okay, దీన్ని బేస్ చేసుకొని c వాల్యూ చెక్ చేస్తారు. కంపల్సరీ c ఎట్ రావాలి. ఒకవేళ ఈ కండిషన్ సాటిస్ఫై చేస్తే c must be belongs to minus 1 to plus 1 మధ్య రావాలి. First, what is f of x here? f of x is x cube plus x minus 4. First, I want to find f of a value, f of b value separately. So here a equal to lower limit minus 1, b equal to upper limit 2. So a equal to minus 1. Therefore, f of minus 1 will become minus 1 whole cube plus minus 1 minus 4. So ఎంత అవుతుంది? Minus 1 will become minus 1 minus 1 minus 4. It is minus 6. Okay. Similarly, b equal to 2. b equal to 2 means f of 2. So it is 2 cube plus 2 minus 4. This is 8 plus 2 minus 4. So this is 10 minus 4, 6. So f of b is plus 6, f of a is minus 6. ఈ రెండు ఖచ్చితంగా నాటికల్ రావాలి. ఒకవేళ ఈక్వల్ అయితే దెన్ అగైన్ ఇట్ విల్ గోస్ టు రోల్స్ థీరం. నేను లాగ్రాంజ్ చేస్తాను ఖచ్చితంగా దీస్ టూ మస్ట్ బి నాట్ ఈక్వల్ ఉండాలి. సో f of minus 1 is minus 6, f of 2 is 6. So then what is again I want to find f dash c value. So what is f of x here? f of x is x cube plus x minus 4. What is f of c value? Just convert into c multiples.
C
c cube plus c minus 4. For this, take differentiation with respect to c. Okay. Therefore, f dash c will become
3c square plus
3c square plus 1. Okay. This is f dash c value. Now, I will going to substitute this f dash c values, f of a value, f of b value in f dash c. So, what is our theorem statement? According to Lagrange's mean value theorem, f dash c will goes to f of b minus f of a by b minus a. So f dash is 3c square plus 1 equal to f of b 6, f of a minus 6 by b 2 minus of a means minus of minus 1. So 3c square plus 1 equal to 6 plus 6, 12 by 2 plus 1, 3. So we'll get 4. 3c square plus 1 equal to 4. From this 3c square equal to 4 minus 1 means 3. From this 3 cancel. C square equal to 1 means what about c value? Yes, c equal to plus or minus 1. So I got two values, but whatever the statement, there exists at least one element, one or more than one కూడా ఉండొచ్చు. నాకు ఇక్కడ 2 పాయింట్స్ వచ్చింది. 2 లో ఒక పాయింట్ నాకు ఇంటర్వల్ మధ్యలో పర్వాలేదు. So I got c equal to plus or minus 1. So c equal to plus 1. Check చేద్దాం. Is it plus 1 belongs to open interval minus 1 comma 2? Yes. Always it is 1 is belongs to minus 1 comma 2. Yes. Hence Rolle's theorem is verified. ఇంకో పాయింట్ చూద్దాం. C equal to minus 1. Minus 1 does not belongs to 1, 2 because -1 does not belongs to open interval -1, 2. Other closed interval 1, 2 ఉంటుంది. But our statement is he belongs to open interval -1, 2 మధ్యలో ఉండాలి. So among these 2 points, one of the point belongs to open interval -1, 2, but the remaining point does not belongs to me. Yes, నాకు ఒక్క పాయింట్ సబ్స్టిట్యూట్ అయినా yes, then I can say hence the Lagrange's theorem is verified. Okay, అర్థమవుతుందా? Hence the Lagrange's theorem is verified because one of the point is belongs to -1, అర్థమైందా ప్రాబ్లం?
Yes, sir.
Yes, sir.
మీరు ఇక్కడ ఏంటంటే yes, come to a statement ఏంటి? Yes, the Lagrange's mean value theorem states that if f is a continuous and closed interval a comma b and f is a differentiable and open interval a comma b, then there exists at least one point c which must be belongs to open interval a comma b అయినప్పుడు f dash c will be, what is f dash c value? F dash equal to f of b minus f of a by b minus a. This is Lagrange's theorem. నాకు ఈ ప్రాబ్లం ఏంటి? In this problem I got c are two values. One is +1, one is -1. Among this c equal to +1, this one is belongs to open interval -1, 2. Therefore, for this example, Rolle's theorem is verified. Lagrange's mean value theorem is verified. Okay. Let me take one more example. On application problem చేద్దాం. Yes, చూద్దాం. One problem. Yes, I will share the screen. Yes, మీరు ఈ ప్రాబ్లం చేసుకోండి. ఇది కూడా సిమిలర్ ఎగ్జాంపుల్ చూడండి. ఇది f of x equal to x into x minus 1 into x minus 2. Product of 3 functions ఉన్నాయి. So interval into whatever interval 0, 1/2. So for this take f dash c and f dash c finally I got 3/4. Is it 3/4 belongs to 0, 1/2? Problem చేస్తారు కదా, జనరల్ ఎగ్జాంపుల్ ఇది. Okay, it also belongs to algebraic equation. F of x equal to x into x minus 1 into x minus 2. We have to check out Lagrange's mean value theorem for this problem in the interval 0 to pi/2. So I got x equal to c equal to f dash equal to 3/4, and from this 3/4 that c root is c equal to 6 minus root of 21/6. Okay, 6 minus root of 21/6. Is it belongs to 0, 1/2 interval? What is root 21 value? Root 21 ఎంత వస్తుంది? Roughly approximately will get 4 point something. Root 16 means 4, root 25 means 5, root 21 means it is in between 16 to 25. So root 21 will be exactly 4 point something వస్తుంది. 4 point something ఎంత అనుకోండి. 6 minus 4 means 2. 2/6. 2/6 means 1/3. Yes, 1/3 always belongs to this interval 0 point something, 0.12. So hence the Lagrange's mean value theorem is verified. ఇది సిమిలర్ ఎగ్జాంపుల్ చేసుకోండి. నేను log x చెప్తా చూడండి. ఓకే, Lagrange's function. Yes, f of x equal to, in your textbook page number 142. Yes, ఇది ఒక ప్రాబ్లం స్టార్ట్ చేస్తాను చూడండి. What is f of x? Yes, ఇది exercise problem example, exercise problem 2, page number yes 142, exercise problem
143, sir.
143. Okay, 143. Exercise 2. Verify the Lagrange's mean value theorem for the function f of x equal to log x in the interval 1, e. Okay, e means 2.71282 e value. Yes. See here, f of x equal to log x. So first write down that conditions. F is continuous on closed interval 1, e. Yes, f is differentiable on open interval 1, e. Then there exists at least one point c which is belongs to open interval 1, e is such that f dash c must be equal to f of b minus f of a by b minus a. Okay, so check this. First I want to find f of b value, f of a value, then f dash c value also. First, what is f of x here? F of x is
Log
log
X.
x. So what is f of a? In the place of a, here we have a equal to 1. So f of 1. So log 1. What is log 1 value?
0.
0. Next, b equal to e. So b equal to means f of b. That is f of e. F of e means log e. So here anything is not given means it is natural logarithm, base e. Okay. Log e to the base e. What is log e to the base e value?
1.
1. Okay.
1.
So I got f of a equal to 0, f of b equal to 1. Then f dash equal to f of x equal to log x. So what is f of c? Log c. So take differentiation with respect to c. So f dash c will become log c differentiation 1 by c. So I got f dash c value, f of a value, f of b value. Then substitute all these values in this equation 1. That is f dash c equal to, according to Lagrange's theorem, f dash equal to f of b minus f of a by b minus a. F dash c means 1 by c, which is equal to f of b. F of b means 1. F of a means 0 by b. B minus a. B means e. A is 1. So e minus 1. So 1 by c equal to 1 by e minus 1. From this, what is c value? E minus 1. Okay. Is it e minus 1 belongs to 1 comma e?
Yes, sir.
Yes, e is here. E is 2.71828 value. 828. What is e minus 1 value? 2.71828 minus 1 means 1.71828. So this 1.71828 always belongs to 1 comma e. Okay. ఈలకల్ మనం సబ్ట్రాక్ట్ చేస్తున్నాం మళ్ళీ వచ్చే వాల్యూ ఖచ్చితంగా దీంట్లో ఉంటుంది. దిస్ ఇస్ సి. హెన్స్ ద లాగ్రాంజెస్ మీన్ వాల్యూ థియరమ్ ఇస్ వెరిఫైడ్ ఫర్ దిస్ ప్రాబ్లం. ఓకేనా? చేస్తారు కదా కొన్ని ప్రాబ్లమ్స్, మీరు కొన్ని ఎక్సెల్ ప్రాబ్లమ్స్ ప్రాక్టీస్ చేసుకోండి. స్టాప్ చేద్దాం. 11:12:33 కదా. ఈ రోజు చెప్పిన ప్రాబ్లమ్స్ అర్థమైనాయా? లాగ్రాంజెస్ మీన్ వాల్యూ థియరమ్ ప్రాబ్లమ్స్.
Yes, sir.
Yes, sir.
నెక్స్ట్ క్లాస్ ఐ
Important
విల్
sums చేయండి సార్.
ఏంటమ్మా?
సార్ కొన్ని ఇంపార్టెంట్
ఎగ్జామ్
క్వశ్చన్స్
కి ఇంపార్టెంట్ సమ్స్ చేయండి సార్.
నేను కొన్ని ఇవన్నీ కనుక లాస్ట్ క్లాస్ రేపు ఉంది. రేపు నేను అన్ని ఇంపార్టెంట్ క్వశ్చన్స్ ఇప్పుడు చెప్పిన టాపిక్స్ వైజ్ ఇంపార్టెంట్ క్వశ్చన్స్ షేర్ చేస్తాను. ఓకేనా?
ఓకే
వాట్సాప్ గ్రూప్ లో షేర్ చేయండి సార్ బెస్ట్.
Sure. So today whatever the problems we discussed today, and problems on Rolle's theorem as well as problems on Lagrange's theorem, all these are important problems. Okay. Tomorrow I will explain the problems on application problems on Lagrange's theorem. కొన్ని application problems ఉన్నాయి. అవి ప్లస్ Cauchy's mean value theorem డిస్కస్ చేద్దాం. ఓకే. స్టాప్ చేద్దాం.
ఓకే సార్.
Thank you, sir.
Thank you, sir.
Okay. Yes, do you have any doubts?
No, sir.
Shall we stop? Right. Let us continue next class.
Okay, thank you, sir.
Yes, very good. Okay.
Hello, sir. Hello, sir.
Yes.
సార్ ఒకవేళ రూలర్ స్థలంలో లాగ్ లో ఏమైనా అడుగుతారా సార్? లాగ్
అడగొచ్చు. ఎక్కడ అడగొచ్చు. నువ్వు ఎటు తిరిగి కండిషన్ చెక్ చేసుకున్నాలి. ఇక నాకు ఎఫ్ ఆఫ్ ఏ ఈక్వల్ టు ఎఫ్ ఆఫ్ బి రాలేదు. ఒకవేళ ఈక్వల్ వచ్చితే రోల్స్ థియరంకి వెళ్ళిపోతుండే.
ఓకే సార్.
ఓకేనా? మీకు ఈ క్వశ్చన్ ఈ లాగ్ క్వశ్చన్ లాగ్రాంజెస్ థియరం అడగాలని రూల్ లేదు. క్యాషెస్ అడగొచ్చు, రోల్స్ ఎక్కడ అడగొచ్చు, బట్ కండిషన్ బట్టి చెక్ చేసుకుంటే వెళ్ళండి. ఓకే.
ఓకే సార్.
స్టాప్ చేద్దాం.
క్లాస్